Okay, let's start. Good morning, good afternoon, and good evening for everyone. And thank you for joining us today for this exciting event. And it's a privilege to have such distinguished audience and here to learn from an exceptional researcher. Today we are honored to welcome Dr. Swaleha, an accomplished researcher and advocate for environmental sustainability. Dr. Swaleha earned her PhD in physics from Banaras Hindu University, where her groundbreaking work on atmospheric chemistry took her to the Indian Ocean, the Southern Ocean, and even the coast of Antarctica. After her PhD, she continued her research as a research associate at the University of Colorado Boulder with 17 high impact research papers to her name. Dr. Swaleha had made a significant contribution to our understanding of atmospheric process and meteorology. Beyond her scientific contribution, she is currently working on a book that explores holistic solution for healing the mind, body, and our planet, a testament to her commitment to both science and well-being. She also actively promotes environmental sustainability through her social media platforms, inspiring many to take action for the healthier planet. Today, Dr. Swaleha will share insight from her unique experiences, explore future career paths in meteorology and atmospheric sciences, and she light on the latest trends shaping these dynamic fields. And please join me in giving a warm welcome to Dr. Swaleha. And Dr. Swaleha, the floor is yours. I think you can start to this session.
Thank you, Dinesh. That was such a kind welcome. Such amazing words. Thank you so much. Can everyone hear me? Can you hear me, Dinesh?
Yeah, I can hear you, Dr. Clearly.
All right. So, hello, everybody. Good evening for you guys, or wherever you are. It's morning for me. So, good morning. Like Dinesh mentioned, my name is Dr. Swaleha Inamdar. I finished my PhD in 2022. I did my PhD from India. All of my education is from India. And then after, when I was writing my thesis, I got a job offer to be a postdoctoral associate in the United States at the University of Colorado. And that's when I moved here, and I'm still in the United States. So today I want to just give a kind of a disclaimer in the beginning that this is going to be an interactive session. When it comes to career paths and job opportunities, I don't know what you guys want to hear. There is so much that we can talk about, but also so little when if we summarize it. So it's going to be interactive. I would appreciate if you guys can ask me questions, type in the chat box, or I think there's also a YouTube stream. You can also type it there, and Dinesh can bring the questions here and we can address them. So, with that being said, let's get started. All right, give me a second. Okay. If the screen is not visible or not moving, let me know. So the title of this seminar was kindly given by Dinesh, was that it was exploring atmospheric science with Dr. Swaleha N. It's an amazing title. I love it. But I don't know how much atmospheric science we can explore today. So I took the liberty of changing that to exploring career paths in earth sciences. Um, and I'm very grateful for the opportunity. So let's get started. Before we explore anything in earth sciences or what the career paths could be, let's talk about my own journey. Because the most experience I have is from my own journey and whatever milestones I achieved and the path I took to be here. So, like you can see here, I did my bachelor's in science in India in 2011. After that, I did my master's. Oh, something to note is that I did my bachelor's in physics. I did my master's in physics, and I will tell you why I am highlighting that. And then in 2022, um, I did my PhD. I got my PhD, was awarded in India in the subject physics again, but the topic of my research was atmospheric science. This is an old university in India. What they follow, they follow a law or a rule saying that if your master's is in a specific subject like mathematics or any field of science, then your PhD is going to be the same subject. Doesn't matter what your research is. So my PhD is called physics, but the research was completely atmospheric chemistry, atmospheric science, atmospheric physics, and climate change. So that's why I was highlighting that even though I did my bachelor's and my master's in physics, I ended up doing research or PhD in a completely different field, which I think I can call it earth sciences because it includes atmosphere, it includes meteorology, includes oceanography, dynamics of the fluid dynamics for circulation on the planet, planetary waves and such that. So in one word, I'm calling it earth sciences. You get the gist of what it is. So no matter where you start, you can still come to this field, which is very interesting. That's why this field is called as interdisciplinary. That means that here combinations of different subjects will merge together, like someone who is an expert in math, in statistics, and computational science will come together and still be working as a meteorologist. And I'm sure you guys are aware of that. So let's move to the next one. Like, this is basically what I discussed about, but in a little bit more detail. So when we're talking about studies, career options for studies in earth sciences, what topics are we talking about? So when it comes to earth sciences, we're talking about everything that I already listed: atmospheric science, climate change, environmental science, geophysics, meteorology, oceanography, and other related subjects. So when we're talking about career options, we are including all these fields. And what happens, how can you lead to these fields? Any science subject. So anything from science or STEM. Oh, I use the word STEM because in the United States and also in other countries, it's a popular word. It's an abbreviation to describe science, technology, engineering, and mathematics. So if you're from any of the STEM fields, then definitely you are eligible or you are able to apply for jobs in the earth sciences or in all these fields that I have listed on the left. So chemistry, physics, mathematics, statistics, engineering, or computer science, these are all people with degrees in these fields are sought after in the field of meteorology, in the field of atmosphere, environment, etc. So if you belong to any of the scientific research or scientific studies, if at a bachelor's level or at a master's level, or even at a PhD level, you have great scope to enter into this field if you start planning well in advance. And even if you don't, there's still ways. Let's get to the next slide. So like I was talking about, having a bachelor's, master's, or a PhD. So let's just first go to the graduate degrees, like the bachelor's degree and the master's degree. So if you have a bachelor's or a master's in science, doesn't really matter what subject, to as long as it is the subject that I've included in the previous slide. But as long as you have a degree in science, you can either become a weather forecaster or you can do some preliminary student level or graduate level research for weather forecasting or weather prediction. You can still get into teaching. You can become an instructor if you have enough experience. You can become an instructor at a college, at a university, if you have enough experience to support that. So that means you can go into academia. And the interesting thing is that there are a lot of nonprofit organizations that are looking for meteorologists. So they are looking for people who are more aware about how the laws of nature work or how the forces of nature work when it comes to environment, when it comes to atmosphere. Because there are businesses, there's trade, and there's other practices in international and national kind of economy and trade services, what happens is that they want to know how the weather or how future climate change can predict their own profits, or can predict their company, or can predict what they are trying to do for the future. So this is where the nonprofit organizations or non-traditional jobs come into the picture, where it's not directly related to meteorology or earth sciences, but it is non-traditional because what they are doing, it could be anything. It could be pharmaceutical, it could be engineering for some other kind of a device which is not related to environment, but they could still need an environmentalist or a meteorologist to kind of plan for how the weather is going to be like, and how it could affect how it could affect their plans, how it could affect their goals, what will be the outcome if so and so happens. So you see that this position is so versatile, trying to be a meteorologist or a weather expert or even a weather forecaster. It has so many different options and so many places where you can work. The other interesting thing that I did not mention is working in media. So I'm sure you see news channels and you see that there's a person who comes up on the TV and explains to you what it means to have the weather chart up there or the map and what it looks like, what these symbols are. So that person is a meteorologist also. And that's not a very sought after profession because very few people get into that because it involves other things like being in front of a TV and a camera. But yes, that is also a profession if you are into that. If you want to broadcast yourself on national TV, you can definitely be a meteorologist and be a weather reporter on TV. Now, that was about bachelor's and master's. It does give you a lot of opportunities, but what is mostly not discussed in academia is the importance of a PhD. And whoever is not wanting to do a PhD or is not enrolled in one, no offense to you guys. You do you, you know what's best for you. But I am here to tell you that what happens after you do a PhD specifically in this field. Before I go to how specifically in this field it affects, I will talk about in general what a PhD means. A PhD means that you are able to do your work or your research independently. During a PhD, you have your supervisor, but they only guide you. And the aim of the PhD is to become an independent researcher, to have your own planning skills, critical thinking skills, and have deep analytical skills. And this, however many years you spend doing your PhD, it prepares you for the future. It gives you these skills. Now, whatever subject you have your PhD in, the employer or the person who is going to offer you the job is not going to look, isn't, let me rephrase it, is going to look for your skills rather than the subject or the topic. The topic is important, but the more focus is going to be on how skilled you are as a researcher, how skilled you are as a manager. Because when you are in a PhD role, that means you can be in leading positions. When you have a PhD degree, you can be in leading roles. So you can be a team manager, you can be a supervisor, you can be a principal investigator, that is a PI for your project. So any role, any job that requires expertise, critical thinking, and deep analytical skills, that job is perfect for someone who has a PhD. Now, what happens when you have a PhD in atmospheric sciences and meteorology? I think we have already gone over those things before with if you have a PhD in, suppose my example, I have a PhD in physics and my research is atmospheric chemistry, climate change. I can apply to work anywhere I want. I can work at a pharmaceutical company, I can work at a university in academic jobs, I can be a professor there, or I can be just a planner for meteorology and weather forecasting for suppose wind and solar energy related companies who work for making devices, solar cells or solar panels or something like that. So the opportunities are endless. And that's why I don't even have a list of how many types of jobs you can get because it is endless. It's just difficult to describe. PhD just opens your door for so many opportunities in life. Um, so where to look for these jobs when you want a job? I know that everything today is online, but even online, how are you going to filter? How are you going to find out what's going to work for you? What's legitimate? What's good? What are your choices? How you compare these jobs? So what I did when I was looking for my job was that I spoke to my supervisor about it and I asked him, like, what is, since I was from physics background and my PhD was meteorology, earth sciences, atmospheric sciences. I asked my supervisor, like, I don't know how to look for a job towards the end of my PhD. And he was just stunned. And he was like, okay, you have been only been focusing on doing PhD and not been focusing on the practical world. And I'm like, yeah, that's true. So he told me that there are two ways to get jobs in this field. Um, it's so large. So there's two ways that I think have helped me. And that's what he said also. It is mailing list and job boards. These are very self-explanatory. Mailing list is a list that is mailed to you every week or every day or twice a week. And it has a list of all the jobs that are currently available as in the Met Jobs mailing list as a meteorologist for earth science jobs, for being even doing a PhD as a student in meteorology, for being an environmentalist, or for being a postdoc. All of these jobs are listed for you in a list in like an email that is sent to you every day. Some of these services send emails every day because they have so many job opportunities. Some of them send emails every weekly, and let me tell you, this is gold because there's a lot of useful information in there. You don't have to look for any specific website. You don't have to look for any specific company. You don't have to look for like like you don't have to hunt for it when you sign up for these mailing lists, and you can sign up for them now. It's free. You don't have to worry about the fact that, oh, I will sign up when I'm at the end of my degree or when I have received my degree. But I would suggest, do not wait. Just go on these mailing lists. I have listed 4 or 5 some of them here. I don't know if there's more, but these are the first ones that come up, and Met Jobs is my favorite one. The first mailing list, Met Jobs, is all of them are free. You can apply whenever you want. You just have to sign up. Google Met Jobs mailing list or ClimList mailing list, and you will find these websites. Just sign up for them and you will see what I'm trying to tell you, that every day you will receive emails for job opportunities. And even when you're not looking for a job right now, it'll be good to keep a track of these things, because the more you keep reading them, you know which university to approach for what position, and what kind of like benefits come with what jobs, because these job advertisements are in detail. They will tell you everything. They will tell you about the country requirement, the language proficiency requirement. They will tell you that if it is a remote or online, it's just like a job posting that you find on LinkedIn or somewhere else. But this is specifically for academians, specifically for people in the field of meteorology, in earth sciences, atmospheric sciences. So please look at all of these or any of these mailing lists. Med Jobs is obviously meteorology jobs. ClimList is mostly related to climate change, climate related studies. ES Jobs Net is earth science jobs net. Cryolist is related to cryogenic studies, ice glaciers and all those things. EGU is European Geophysical Union, which is a giant publishing house which publishes a lot of research around the publishes different kinds of research, but also a union for geophysics in European in Europe. Earthworks, again, same. AGU is just like European Geophysical Union. AGU is American Geophysical Union. They have a Pathfinder that is a career guidance Pathfinder, and you can sign up for that or go look it up, and you will see what they have to offer. And same as EarthScope Consortium. I talked about mailing lists, but I did not talk about job boards. So job boards are nothing but when you go to some university website, or when you go to a company website, and when you look at career options, or when you look at work with us or career, that is their job board. That means that under that tab, they are going to be posting about any new jobs that they have, any opportunities that they have, any internships, any visiting exchange kind of related research, So job board is, for the job board, it could be a general, it could be like EGU jobs. EGU jobs will list jobs from all other different affiliated institutes and websites. And if it is a specific, suppose it's University of Purdue job board, then they will have all the jobs for that university in various departments. So that's basically what it is. And when you're looking for jobs, be very specific about what role are you applying for before you start to filter them and start selecting which one works for you. Look at the role, look at what country it is, and if it is a specific country, then you have to find out about the laws and rules and regulations that will come with the job. Language, if you want a job that is in a different language, if you don't want an English speaking job and you want something non-English, you can do that too. There are specific mailing lists for jobs from different countries, like specifically for jobs in China, for jobs in Japan, and you know that there are different websites. And similarly, there's kind of a different way to approach these jobs in meteorology. So for example, if you want to find a job in Japan and you want to know specific jobs that do not require English language proficiency, there's a website that I came across recently. I think it's just Japan/jobs or something. And if you put in meteorology, you can get uh, what jobs you want and what jobs they have in that field, and you can select the option for non-English speaking jobs. And I think this is available everywhere. And after a PhD, you don't even require an English language proficiency test, because a PhD is a testament that you know how to speak and write and talk in English, write and read in English. Anyways, how was it so far? Does anybody have any questions? You guys can raise your hands. What do you think, Dinesh? Can they raise their hand, or is it just a chat question? Oh, yes. Because I don't want to keep talking. This I don't know how to explain more about this topic apart from what I've already done. I Yeah, yeah, yes, absolutely. But no pressure, guys. Yeah. Please ask, and no pressure. Don't feel the pressure to ask any questions. You don't have.
Hello,
Okay. Hi.
hello, hello, Dinesh. Am I audible?
Yes, you.
Okay. Okay. No, not webcam. Thank you so much for that. Hello, doctor. How are you?
I'm good. How are you?
I'm fine, thank you. And doctor, I am here as a PhD student in hydrometeorology, and I have my master's and bachelor's from India,
Mm-hmm.
University of Allahabad. So
Mm-hmm.
I am from Banaras, and also I wanted to ask that I am pursuing my PhD in hydrometeorology here in NUIST.
Mm-hmm.
And can you please help me to describe some scopes in this field, or some organizations which provide internships or something like this in this field? Because I think there's a lot of, let's like comparatively less opportunities hydrometeorology, and I'm also searching in this regarding India. So if you can help me for that, it would be great. Thank you.
Thank you for your question, Divya. That's a great question. So, hi, because you're a fellow Indian and you're from Banaras. I love Banaras. It's the place where I did my PhD at the university. Anyways, great question. Hydrometeorology is an amazing field, and I am so sorry to hear that you're not able to find good opportunities in that field. My first suggestion to you would be sign up for this mailing list. Sign up for med jobs, especially med jobs, because med jobs, they have job opportunities that come up for hydrometeorology almost every day. I'm reading something every other day about hydrometeorology or just hydrology and then GIS, or I don't know what comes in your field exactly, but sign up for the mailing list. You will not regret it. And if you're an like Dinesh said earlier, something about if you're a student and you're just looking for an internship or just a summer program or something like that, these websites are still pretty helpful. These mailing lists are very helpful. The second part of your question was that you want to look for opportunities in India. So you have a specific country, and now you want to know how to look for jobs in India. That's a very good question. Now, what you can do is in India, when you look at meteorology or hydrometeorology, think about what are the governing bodies, what are the organizations that handle this in India specifically, and in any country for that matter. When it comes to meteorology, weather sciences, when it comes to earth sciences, there is one organization that's almost everywhere that handles them. It's called the Meteorological Department. So in India, it's the Indian Meteorological Department, IMD. You can just go on IMD website, look at jobs, and then see what they have to offer for you. Because if it's a meteorology department, it's a government body, it's a government organization, it's going to list at least links for you where you can go, where you can look for. And this is directly going to be under the Ministry of Earth Sciences, because that was where I worked also. So I'm aware of that. So that is my tip for Divya, and also a suggestion for everyone else. If you're looking for a specific country, try to go to their own like general governing bodies. For example, if you want to, let's take the example of United States. If somebody wants to find a job in meteorology in the United States, then my suggestion will be look at the federal labs. Federal labs means the government labs in the United States that are national laboratories that will work for meteorology or earth sciences or atmospheric sciences. The big ones in the United States, we know the name of them. It's NOAA, there's NASA, and there is National Science Foundation, NSF, which funds all of these organizations. So when you go on any of these websites, NOAA or NCAR or UCAR, you will see that their job board will have connections to everywhere else where you can go, any links to related fields. But your job is going to be so much more easier if you just sign up for the mailing list. You just sign up for the mailing list and you don't even have to check it every day. Whenever you have the time, just go through all the job listings that were sent to you and see if you can find anything. And if you find something, just bookmark it, just keep it for yourself and maybe visit it later and see that, okay, and then you will have an idea that what kind of job listing comes for hydrometeorology, or what kind of job listing comes for numerical analysis or numerical weather prediction, something like that. I hope that answered your question.
Yeah, thank
Thank
you so
you.
much.
To use LinkedIn.
Oh, yeah.
LinkedIn is
Okay,
also a
okay,
good
okay.
platform.
Okay. Maybe I'm not searching in right direction. So thank you so much for directing us. Thank you.
Oh, absolutely. Absolutely. Is there any other question, or I can move on to the next one? All right. So I don't have too many slides. I believe this is my last slide, which is so funny because we have so much more time left. So I'm definitely encouraging everyone to ask me more questions. Otherwise, we are out. We are done. I don't have anything else to share. So we talked about how to look for the jobs, where to look for them. And now let's talk about something that's very important and often ignored. And this information is not really given to a lot of PhD or people in academia or people in science, is how to build your CV or how to build your resume for your job. And that's where, especially since English is not our native language, I'm saying our because I'm Indian, it's not my first language. And also I know I'm talking to students at the Chinese university. English is probably not the first language for most of the students, and that is completely okay. But we have to make our resume in English because of how the world works. So I will give you like some tips on what to remember to put in there and what to not put in there. So the first few sections that are important is the first one is an introduction for yourself. Introduction can be before or after the contact details, but contact details are very important, very, very important. Always write your updated email, write your latest phone number, write your latest address, affiliation of your institute, include all of that. And then introduction, you have to introduce yourself, just like I think you have on your LinkedIn profile. You have your, just look at the LinkedIn profile. At the top, you have your picture, you have your affiliation, you have your latest degree and all that stuff. After that, you have contact details are probably hidden, but you have an introduction. There's a little bio that you can write in and introduce yourself. You can say, I'm a physicist. I have done research in climate change. I have done research in atmospheric chemistry. I have so and so experience. I have this is what we found from my studies, and I am motivated to do X, Y, and Z. Or my passion is to keep working in X, Y, and Z field, or look for more options over there. So any introduction, and of course you can take the help of Google and look at samples and make up your introduction. After that, you write about your education, about all of your, right from bachelor's to, or maybe whatever education degree you have, high school, and then go up to your latest. Then talk about your work history. Any work experience that you have, please list it on your resume, even if it is unpaid, if it's an internship, if it's summer work, summer vacation work, just put it on your resume, because I understand that everyone's always going to be like a fresher, a first time applying for the job, but any kind of experience of work in real life counts a lot. Even if it was something that was not related to the current job. Suppose the current job is meteorology and you have a little bit of work experience helping people in your community build houses. Just put it on there, because it still shows you have skills, you have team working in team abilities, and you are willing to help others. So just put that on your resume also. Then, of course, since it's an academic resume, I'm assuming you may have some list of publications or some conference publications, some posters. Maybe some of them receive awards. So do your list of publications and then your achievements. Then your references. References are the names of the people, names and contact details of the people who are going to answer your employer and say that, yes, we know this person, and probably tell good things about you. Uh, Hopefully they'll say like, oh yeah, this person is a good person. I've worked with them before, and yeah, they will be a great addition to your poor job. So write the names and contact details of people who will say good things about you. And before you put their name on your CV, ask them. Whenever you write anybody's name as a reference on your CV, you have to first take their permission, email them, contact them, let them know that you want to put them as a reference on your CV, and then go ahead and do it after you have their permission. Now, the small little things that are often ignored. Now, this block here says, consider formatting according to the specific job. This is really important because in this dynamic field, in the field of earth sciences, if you're really actively looking for jobs, there's going to be days where you're applying for meteorology and, for example, numerical weather prediction in the same day. And these are two different roles. These are two different jobs. They are for you because you have the credentials. They are from your related field, but these are different. So you have to format your CV for every single job. You can't have one CV that you just push it on everyone. That's not going to work. For every single job, every single opportunity that you're doing, that you're writing for, even if it is an SOP, I'm going to talk about SOP soon. It has to be specific to what you're applying for. Now, what do I mean by specific? I mean, oh, I'm sorry. Let me go back. Okay. So I mean that use keywords. Use keywords. Keywords. Keywords are so important in today's world, because what happens when you apply for a job? Hundreds or thousands of resumes and CVs are collected by the employers. They do not have the time to read everything. They do not even have the time to read the names of the CVs that they have received. So what they do is they use a filter, which is a computerized filter most of the time. Of course, it's a software. Um, so they use the filter to look for keywords. Like suppose if the job was for a meteorologist, then they're going to search for meteorology, meteorologist, worked as a meteorologist, all these little words in your CV. And guess what? If you have not used this word, your CV is already rejected even before anything else has been considered, which I think is not fair, because there are so many people who don't know that they need to tailor their CV according to the keywords in the job description. It's literally like if the job description says trace gas analysis, they are going to look for that in the people who apply for the jobs. So if it does not have the word trace gas or trace gas analysis, it's just going to be rejected. So that I think was the key point in me telling you about all this. And the most important, always use all true information. Do not lie on your resume, especially on your SOP. Do not ever do plagiarism. I'm sure you know what plagiarism is. Plagiarism is copying somebody else's work without giving them a citation. So of course, no, you're not doing that in your academia. You're not doing that in your research papers, I hope. But when it comes to CV and SOPs, if you do that, it's a big no. Because even if suppose you were inspired by somebody's work and you try to copy their style, you cannot cite them. You cannot give them credit for that. The inspiration is different from actually like putting that text together and copying it and just changing it a little bit. So always make sure that whatever you're writing for your jobs, whenever you're making your CV or resume, CV will not be plagiarized as much, but SOPs, they do get plagiarized. And as soon as they detect, because it's a software, it's going to detect your plagiarism no matter how badly you try to hide it, and you are going to be rejected. So please avoid that. Please avoid that. That's where I end. Now, I have more things to discuss, but it's more like Google search, which I can do. I can share my screen and show on the websites because
It's like most mistake in the CV, building the CV. Because
yeah.
when you are applying for some jobs, they use typically ATS system, application tracking system. So those systems only look for the keywords.
Yes.
Sometimes I know some guys are like beautifying their CVs using lot of colors and multiple text and like multiple fonts. So typically your CV should be in like plain white and like black text. So it will be easy for those softwares to read. Sometimes you like create your CV by adding like lot of colors and like different decorative fonts. But when you submit that soft copy of the CV and like when they try to read using these ATS softwares, they like fail to recognize your text. Sometimes at that point your CV will be rejected.
Yeah. Um, I have a question. Dinesh, do you still see my screen, or do you see something else coming up?
Doctor, still we are seeing your presentation. I think
Okay,
when
great.
you are sharing you have to share the web browser or something. If you need to change it,
Okay.
you have to stop sharing and then you have to reshare it.
Yes, I want to share a live example of how a job listing looks like from MedJobs, because that's my favorite mailing list. They send a lot of emails, and they have a lot of opportunities. And what happens is that if you apply for too many job links, then you will see cross posting. We don't want that. So let me open up a job listing for you. Let me see if I can find something in hydrometeorology for Divya. Yes, I'm switching. I'm opening the email. All right. Do you guys see this? So it says med jobs postdoc in data-driven hydrometeorological forecasting at KIT, Germany. So you can tell that this is my med jobs mailing list that I have signed up for. I just received this email from them. It says it does have a attachment, and it says we are inviting an application for 3-year postdoc position with an interdisciplinary project on AI-based flood prediction in small river basins in Germany. The postdoc will be a part of working group of Peter Knippertz at the Institute of Meteorology and Climate Change and all those details. Oh, and look at that. They also come with the official posting, which has a lot more information, requirements. First thing it says is PhD, and the subjects that it talks about is atmospheric science, applied physics, mathematics, statistics, or equivalent. So when I was talking about the subjects, this is what I meant. If you have a degree in science or STEM field, and if you have a PhD also in science, when it comes to the interdisciplinary fields like earth sciences and meteorology, it doesn't make a big difference. It really doesn't make a big difference. You can have a PhD in physics or applied physics and still be able to do a postdoc in meteorology, given that you have had some experience in that field, given that you have done some studies in that field. The subject does not really matter. And we had this idea in India. I don't know if it's a common thing, but before I did my PhD, I had this idea that if I got my degree in physics, I will not be eligible for atmospheric science jobs. That was such a silly idea of what I had in my head. And then I realized that the subject rarely matters. Okay. So let's look for keywords. Are we going to find any keywords here? I think here. I think some keywords are here. The postdoc will focus on development of ML-based post-processing models for optimizing meteorological forecasts to serve as inputs to hydrological flood forecasting models. There are so many words here already, and the keywords are going to be like, if someone wants to raise their hand and give me an example, I would love that. But let me go ahead and start. The first keyword is going to be ML-based, ML-based. That's just going to be a keyword because they're going to search for someone who has experience with ML-based models, post-processing models. Then the next keyword is going to be meteorological forecasts, or it could just be forecasts. The next one could be hydrological flood or hydrological flood forecasting model. That entire thing could be a keyword, or separately hydrological, separate flood, separate forecasting and model separate. So this was just an example that I was trying to give you, that if you're willing to apply for this position and you see that you have no way of using these keywords, that means that you're not eligible for this, because this is what they're going to look at. They're going to look at how much experience you have in this, basically what they want. So that was an example. Let me show you, let me share a website with you for what I found when I was looking for more job opportunities and options. And in the meantime, if you guys have any question, please feel free to ask.
We also have some bachelor students in here as well. They are doing purely AI, so now they know, like, if they focus on meteorology related something, then these kind of opportunities are there. They are purely their degrees related to AI and machine learning things. So now you guys know what kind of fields that you can like focus on.
Yeah, there are options on this website for machine learning as well. In fact, let me share one, since you said people are interested in it. Share my screen. Sorry for the delay, guys. I'm just slow this morning. Okay, I think I found a good one.
Hello, doctor. I have a question.
Hello, do you have
Yeah,
a question?
yeah, actually, I thank you very much for this brief, insightful talk. It's really rich. Thank you. The question, anyway, my name is Abubakar Sadiq Tanimu, a master student from NUIST. I don't know, is there any way you can relate this to renewable energy? Like,
Oh,
can
yeah.
we explore opportunities in renewable energy with respect to this topic of meteorology, climate science, and other things?
Oh, yeah, absolutely. Thank you for that question. That's a great question. So, when I said meteorology, climate science, and climate change research and all that stuff, I called it earth science. So everything that's natural and that's on the planet Earth and it's about the planet Earth is included in this topic, is included in whatever we are talking about. It's included on the MedJobs mailing list, the CLIM list mailing list, other job boards. They are all connected fields. They're all interdisciplinary and they're all connected to each other. So if you're talking about renewable energy resources, sustainability, environmental development and sustainability, these are all very, very, very high demand topics in this field, in this field of earth sciences. Oh, there's something that before I go to the machine learning advertisement for the job, I want to talk about the the trends in this field. I did not make a slide for that because I didn't know what to do for it. But let me tell you what the trends have been. You are all aware that we are experiencing we were experiencing global warming and now we are calling it climate change, and we can see the effects of climate change and how the studies that focus on finding trends and patterns in climate change are becoming more and more popular. Is more on some things like uh, preserving the renewable energy resources, finding alternative solutions that are more sustainable, less harmful, and focusing on climate change research. These are, I will say, the hot topics. These are the topics that people are looking for employers to work with. And they also need meteorologists to begin with, because meteorologist will be the main guy who kind of like can expand into all of these other fields. But like I said, anything related to Earth that is natural, related to the resources from the planet, related to the water or the soil moisture, all that studies, anything related to air, fluid dynamics, or any other like jet streams and things like that, or the atmosphere in the outside, even the troposphere or even the ionosphere, even space related studies, also like geophysics, everything comes in the earth science category, everything. So that's why I like the word earth science better, because it includes everything: water, atmosphere, soil, includes also, it just includes earth, but there's also planetary science in it. Planetary science meaning study of the atmosphere that's above the free troposphere, the study of atmosphere that's outside the atmosphere, basically. So yeah, I hope that answers your question. When you sign up for this mailing list, I can definitely find a job for renewable energy and show it to you right now that, yeah, there you go, it's already available.
Thank
Uh,
you.
Sure. So now look at this one. I think Dinesh mentioned something about machine learning, and he said that students are interested in AI and machine learning jobs. There's a great opportunity for machine learning, deep learning, and AI in earth sciences, in atmospheric sciences and meteorology, because we're still trying to understand these fields better. I'm sure you guys are aware that AI and machine learning means that pooling a lot of processing systems together and running your your models on many numbers of processors and doing a lot of computational calculations that are expensive, that may also take a lot of time. And but you're able to look at a lot of permutations and combinations to find your result, because that's what weather prediction, or that's what meteorology is like. You have so many variables that you put into a system, and then you let the system process it, and then you look at the output. But the input that goes into the system is very important, because if you don't understand that, you don't know what the outcome is going to be. And the processing parts in between, which is machine learning and deep learning, is just basically looking at trends, training the machine, and then finding what could be the most likely outcome, which makes weather prediction kind of easy, I would say, but there's so much more work that needs to be done in this field. We don't even know, even now, how much we can rely on machine learning when it comes to earth sciences, how much we can rely on deep learning. So this is definitely a booming field. If people are interested in it, here's an example of the opportunity. I think this is already expired. I'm opening some old ones here, or maybe not. And it talks about postdoctoral research fellow for 2 years. They also tell you what they're going to pay for it. Blah, blah, blah. What will be the keywords? I think here, latent space data assimilation for global weather forecasting and use of alternative loss functions in ML-based weather forecasting. ML again, machine learning. It's back again. So yeah, this was another example to show that sign up for the mailing list. That's my that's my end statement. Sign up for the mailing list. It's free. It's just like receiving a magazine for free every week, and then just browsing through the magazine and seeing that if you find something you like. Okay, guys, technically we have 1 more hour. So any questions? And if there are no questions, I am going to show something related to my journey or my own PhD experience, to give you some idea of what kind of work I did and how it kind of blew my mind that I did not imagine my journey to end up the way that I thought that it did. I did not imagine it, because I was focused on only physics, and I wanted to do research in either theoretical or experimental physics, and I did not want to change my field. But I think I have like a great story to tell you guys and show you what happened um, when I just trusted the process.
And Doctor, one of our attendees was asking from me like personally, and like she was asking regarding why did you choose PhD on atmospheric sciences?
That is a great question. That is a great question. I will be very honest with you guys, because I still consider myself to be a student. I only got my PhD in 2022. It's been what? Oh my God, it's going to be 3 years soon. But I still consider myself a student. And this talk, I thought that it's just going to be me talking to junior students from my college or university, and that's how I took it. So the question why I chose a PhD in atmospheric science, very honestly, I did not choose it. Very honestly, I did not choose it at all. In India, there is a when you grow up in India, what happens is that your parents decide what you're going to be. The day you were born, that day it's going to be decided who you're going to be as an adult or in the future. So it could either be a doctor or an engineer. At least in India, I'm being very honest. So you can be a doctor or you can be an engineer. And I was born in the 90s. I'm born in 91. So I definitely experienced that a lot. So my parents decided that since I was a girl, I was going to be a doctor. I'm really like shaming my parents right now, but this is a funny story. So they decided that I should be a doctor, and they just pushed me to, hey, be a doctor, do science, do science. And then I was already interested in science, so I kept doing science. And then comes the day when I am in my 12th grade and I'm in my chemistry class, and I'm having a lot of fun. Chemistry and physics were my favorite subjects when I was doing my 11th, that's high school, 11th and 12th. I just love those two subjects. And one of my chemistry teacher asked like a question on the board for organic chemistry, and he had like a difficult solution for that. And he asked in the class who was willing to solve the equation for him, and I did. So he was really proud of me, and he told me, you know what, you should try and pursue a career in science. And I was like, huh? So he was like, yeah, you should try and do a PhD. And I was completely shocked, because the only other time I heard of a PhD was when I was in school and a classmate of mine raised his hand and said that I want to be a scientist. And that was the only time I heard of it, because in India, in my house, it was just doctor or engineer, nothing else.
South Asian
Yeah.
countries.
So my teacher did advise me to consider master's in science and then probably consider a PhD in science, because he came up to me and said that don't go for the regular doctor and engineer profession that everyone's here preparing for, but try to do something else. And then what happened? In 2 years, I failed my entrance test for the medical school. It was a very heartbreaking moment. My entire family was mourning. It was a very depressing time. I don't know how I survived it, but here I am. Uh, so yeah, I could not go into medical school. So I took my teacher's
I think
advice.
in here also we have some guys like that. They also can like share their experience as well. This is like just a friendly discussion like regarding your career thing and everything. So we can like share our opinion.
Yeah, of course. So
I saw
I
like
didn't.
lot of guys are participating in here. By the way, Dr. Swaleha is like joining with us from like USA, and for this time she is like for her it's like in the morning, and for us it's
Yes.
like in the like almost the midnight. So that's why like sometimes some guys will ask like why we go for like 8 p.m. Typically our all the activities are going till like 6 to 8 or something like that, and then they will confuse like why we choose 8 to 10. So guys,
Oh,
if you have any question, you guys are feel free to ask.
even if you want to share something, please go ahead and share. This is just a casual chat. This is not heavily monitored or heavily looking for a
Uh,
direction. Yeah.
Hello,
Yes.
I'm Martha and I'm doing a master's in meteorology. I would like to know what are some of the main skills you would recommend someone like me doing a master's in meteorology to nurture.
Okay. That was a good question. You want to know about the skills for doing a master's in meteorology, correct?
No, as I prepare for my future career, what are some of the main skills that I need to nurture?
Okay. That is a very good question. So no matter what your future job is going to be, employers or people who give you the job, they look for few specific skills that I had mentioned earlier. Critical thinking, ability to do independent work, and analytical skills. Because to solve any problem that comes in front of you at your job, no matter what the job is, you need to have a clear thinking or a clear understanding of the subject that you're working on. That is a given. That never goes away. Clear and deep understanding of the subject is more important than ability to think outside the box, especially when you're doing research. There's no hard and fast rule there. You have to find out what the problem is. So ability to think outside the box and have logical reasoning and analytical skills. How do you focus on these skills and how do you improve them? I think that will be the next question. Okay, these are the skills, but how do I improve on it? Of course, to get the expertise on your subject, you have to master it. You master your subject on your own. Just keep studying, Be active on forums, be active on ResearchGate, where people ask questions about that field. Keep reading about the latest publication in the subject that you like, in a topic. If you like to read about glaciers, then read research articles on glaciers and sign up for the journals also. I think that's something that I did not mention, because journal sign up is mostly for to gain your knowledge, to increase your knowledge. But there are so many journals that will offer it for free. They will send you their articles as they are published, and they will also give you, like, sometimes they give you a hard copy, a printed copy for a small fee. So if you can do that, you can get that too, and just keep yourself updated. Read every day. No matter what subject it is, but read something new every day, because research is happening every single day. There are so many publications that come out every day. Just this was a thing that my supervisor recommended, that every morning when you come into the lab, when you come on your desk, read first. Read whatever was published last week, this week, a day ago. Just go through it, because updating yourself is the best way to make sure you still have a grip in your field. Otherwise, that grip will loosen very fast if you stop reading about what's going on in your own field. So I guess that's my advice, and that was the answer to your question, Martha. Thank you.
And just to complement to the reading part, I just want to share Dr. Swaleha just published a book. So you can also go check it online and contribute yourself to the reading habit.
Sadashiv, thank you very much. You're very sweet for saying that, but that book is completely different. It's not related to academia or science. It's a great
Just for
suggestion. I
the
appreciate it.
exercise. Just as
I
a
I
reading
meant
suggestion.
read research articles every day. Reading is good anyways. Reading is very good for your brain. It helps your brain stay healthy. But I meant read research articles, even if you read a little bit about what's going on in your field. It's the best way to keep your skill, to show that you're on top of things, to have your expertise, to master. It's called mastery. It's called mastering your skills every day. It's something you have to commit for every single day. Do it over and over again. And by the time at the end of your course, when you're ready for your job, you're going to realize that you already have these skills, because you've gone through the process of a master's or a bachelor's or a PhD. And these programs teach you these skills. So just don't deny it. You already have these skills. I'm trust me, all the students who are already here, I am pretty sure they have good logical reasoning, they have analytical skills, they have reading skills, they have communication skills, both verbal and written. So when I talk about the mindset that comes into play in the job market, just believe in yourself. Trust yourself, trust your abilities. You have the credential, you have the degree to show that you have done this program. That means you are capable and you have passed it. So, have that faith in yourself. That's something that I did not mention, because journal these skills. And this is something that I had to learn, because we become so humble. The academic surrounding makes us so humble, saying that even if you have a PhD, you don't know anything. They really like to say things like that, but that's not true. You have to realize what comes with your degree, what benefits, what it teaches you, what you have learned, and you have to be confident about speaking that about yourself. If you have a bachelor's, just a bachelor's, you be proud of it. Be very proud of it and be confident that, yes, I have a bachelor's degree in science. I know this, I know that. I can solve, I can research, I can do more, I can go for a master's. Just be confident. Okay, now, since it's been quite intense, let's go to the story of my PhD. Let me share the screen. All right. Share screen. And please let me know when you want to end the session, because I feel like at this point we have discussed everything that was on the docket for, like, apart from my journey, that was on the docket for the seminar. I like I said, I could talk at length about these things, or I could just summarize it in short, and then the rest is up to you to Google and to check and sign up for these mailing lists and such. But if you want to leave at any point, you feel free to leave. I don't know if Dinesh wants to comment on that because I'm not going to continue it for another hour. I maybe just a few minutes, just 10-20 minutes. What do you think, Dinesh? Okay.
Yeah.
Okay. Okay. Do you see the link? Is it visible? Okay. All right, guys. So since this is just a discussion and I was invited here to talk about my journey, so let me talk about that a little bit. I have already given you the background as in a medical doctor, not a PhD is. So don't even go there. They wanted me to be a medical doctor, go into medical school. So I started to continue with my science because I was already studying science to go to medicine. So I decided I was confused between physics and chemistry since I liked them both. I decided to do my master's in physics, bachelor's in physics. And then since I was not going to medical school, I decided to do my master's. Just because I did my master's, I thought of doing my PhD because why not? Why stop here? Let's just keep going. So that's basically pretty much how it went. In physics, as in the research that I was doing before I came to meteorology and atmospheric science. So I have also done some research in physics, in semiconductors and quantum physics. And I published, I think, 2 papers from that. And I wanted to continue that as a PhD option, but that didn't really work out. So I started applying to interdisciplinary fields. I started applying, and I think meteorology was the first one that I did. And I got the opportunity to do my PhD at a meteorological institute, which is this one right here. My pointer's gone. Okay, this one right here, Indian Institute of Tropical Meteorology. This is the place where I did my PhD. This is their logo, and this is the university logo where I got my degree from. So this presentation that I'm sharing with you is actually the thesis submission. So this is my PhD Viva voice. PhD Viva. And why I want to show it to you is because I feel like this can summarize my journey really well. Like really, really well. I don't have to say anything else if I show you this. And we will not go into more details. We will keep it like a story. So look at the first 2 pictures on the left, top left and right. Aren't these beautiful? It's a ship, it's a research vessel that is sailing in the ocean. So here, the ocean water is actually Southern Ocean. We are going towards Antarctica. And here we're very close to Antarctica. We're at the coast and everybody's standing here to look at what's going on. So the Southern Ocean and the Antarctic coast was based on, that was the region of study. And this study was iodine chemistry in the Indian and Southern Ocean marine boundary layer, in the marine boundary layer in this region. I'm going to skip all the slides that don't add to the story, basically like the introduction for my topic, what was the rationale behind doing this research, why I picked iodine chemistry, all those explanations. Like these are the most important questions. You need to know these questions when you are doing your PhD. You need to know why you selected the topic. You need to know what is missing there. What are the gaps? What are you trying to fill in? What are you going to add to the topic? So this is what that is. And now this this is something I really like because this explains my research in just one picture. All of my research is based on these two elements in the water. Iodide and iodate in the water reacts with the hydrogen, makes these two aqueous solutions, then releases a gas. Gas reacts with light, forms iodine, reacts with ozone, forms iodine oxide. And then I look at the iodine oxide because this can affect the climate because it acts as a cloud condensation nuclei. It makes clouds, and there's albedo. It changes the radiation budget. I don't know if you guys are aware about what the radiation budget is, but basically it's the incoming and outgoing solar radiation on the surface of the Earth. So it's kind of like a calculation of that to see effectively if the Earth's surface is getting heated up or if it's cooling. So the iodine oxide gas has a tendency of affecting the radiation budget. That's why it gives us the climate change importance. And these are the famous equations that basically show how these two gases are formed. So that was the crux of my thesis. Like the main principle, the main idea of my thesis lies in this one slide. Oh, I also want to highlight the importance of having graphical representation in your work. So because if I had to just talk about it, I can just talk and it will be very boring and lengthy. But as soon as you have a graphical representation, you have a picture in there. It's concise, it's beautiful looking, it grabs attention, and people understand it much better and faster. All right, boring equations, nobody cares. Oh, this is cool. So this is a missing gap in my study. Why we chose this region? Because this is India, right? The Indian Ocean, this is the Southern Ocean, and this is the coast of Antarctica where we went to. Now you see the blue dots are everywhere else, but there's no blue dot in this region. Like in this entire region, there's no blue dot. The blue dot represents previous studies. It has the location of where the iodide was measured and a compiled data set was made. And we definitely realized that where we are working is the blank, where there's no data ever recorded. So my thesis was the first study in this region to record the data for iodine and iodine gas. Same thing, again, incomplete region, except for these two few of the points there for iodine oxide gas. And what was interesting was ocean iodine in that region, but when they measured the iodine oxide gas, the concentration is somewhere here, correct? So it means that there is the presence of that gas in the atmosphere, but it wasn't studied. Anyways, so my main PhD was based on these three questions. And each of these three questions made up my three topics or three objectives of my PhD. The first one is just how much of iodine is in the marine boundary layer. Simple question. We can find out, we can study it, we can measure it. So that's what we did. And that was my first objective. The second one is what are the sources of iodine? So this was not so easy. This was kind of tricky, because even now there's a lot of missing information about it, but we were able to shine some light on that topic. That was my second objective. And the third objective was what is the impact of iodine chemistry? So this is where the climate change aspect comes into the picture, because here in this objective, I looked at iodine chemistry, how it reacts with other gases, how it recycles in the atmosphere, how the heterogeneous chemical reactions form other gases, how it affects the cloud formation, how it affects the radiation budget, if it affects the tides and things like that, and what kind of impact it can have in the future if the same amount of iodine oxide related like cloud condensation nuclei are forming clouds. So that was my third objective. So a PhD is basically simple. You have either 3 or you have 4 kind of objectives, and every objective is answering a question. If you look at it that way, it's so simple. Your PhD can just become 3 questions and 3 answers. And those 3 answers will be not so easy, but it makes life much easier. All right, so from the 3 questions, I had technically 4 objectives. The first one was just taking observations. So yeah, that I wanted to show you guys. It's, 1 second. Yeah, so this is the ship, the research vessel called S.A. Aguilas, to go to Antarctica and to collect our data. And here I have pointed the location of right here. This is the instrument in that location. If you zoom in from there, this is the instrument. It's called the MAX DOAS. It's an outdoor telescope unit. This is how it looks from back. This is how it looks from the side. And this is the telescope. It has a little prism inside it. And here is the spectrometer, which is both UV and visible range. And here is the computer that basically looks at the data collected by the telescope. And this is obviously me working on my instrument. So it was almost a surreal experience. Like, I cannot believe that I went to Antarctica coast, and I went there twice, not just once, but twice. I am so blessed for that. And it was just something that a PhD of physics, not a PhD, but a physics student would never imagine. As a physics student, my mind was mostly in numbers and mathematics. And I was trying to read about quantum physics and semiconductors and quantum dots and stuff like that. So I never thought that I would go to Antarctica. So the best thing that meteorology or Earth Antarctica, because if it wasn't for the earth science switch that I made, I would not have experienced this. And I'm not just saying that go to Antarctica and do meteorology. I mean, that will be, you can go to Greenland, you can go to Iceland, you can go to Arctic, you can go where, and studying about the earth is the most fascinating thing I've ever done. Studying about the laws of nature. Like, what is physics? Physics is just laws of nature. And earth sciences is actually learning and studying about them in practical on earth. So that I think was great. Very, very glad that I made the switch. Very glad that I chose this subject, because I have curiosity. I have a love for research. So it was just best of both worlds for me. It was physics, and it was all this field work, going to amazing places, meeting amazing people, talking to people from different languages, from different countries, and learning. And doing a PhD in itself is such an experience. It took me such an experience. It took me 6.5, about 7 years to do my PhD. In India, that's how long